Today we want to begin our Geometry Lesson 71 with Investigation 7 Part 2. First, we're going to do a very quick review. On page 70, we were introduced to the terms sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent of an angle, which is opposite over adjacent. For our Smart Sheet, we do want to have all of these written down. You don't have to have the letters with it unless you need it. The definition of those positions is on this triangle. Our two special triangles are our 30, 60, 90 and our 45. With our 1, 2 square root 3 and our 1, 1 square root 3, 1, 1 square root 2 written down and labeled. This section right here is an excellent introduction for you to the trigonometric functions of sines, cosines, and tangents, all relating to right triangles, with many different degrees that go actually between 0 to 360. So I hope that you have put these strings, labeling them, drawing them on your Smart Sheet, and these three, they do not have to take up that much room. One extra note on your page 470, the chart that is listed there is in a different form than what I wrote in the lesson. Please copy the chart on the lesson in the book and use that chart for your answers. I only showed mine to show the relationship between sine and cosine. Your chart will be much easier to fill out. Thank you. Going to Part 2. Page 472 of your text begins Lesson 71. I'm going to begin with some vocabulary. First of all, with a transformation, one of our terminology that we've learned, pre-image is the original position. Image is the term for the new position. And the next term is isometry or isometry, depending on how you want to pronounce it. I pronounce it iso, which means the same, and metry, which means measure. So isometry means same measure. It can be in a different position. It can be flipped over. It can be upside down. You demonstrate a transformation of isometry all the time. If you're in your front door, you are the same measure as if you are standing in the middle of the kitchen or if you are standing outside before you get into the car. All you're doing is changing your position, but all of your measures are the same. Going on to translations. A translation is an isometry, meaning the pre-image and its translated image are the same size and shape, same measure. Let us look first at example 1, translation in one direction, one dimension. We have labeled points A, B, C, D, when connected. Make a rectangle. We are going to translate it over here to A prime, B prime, C prime, and D prime. So A prime moved from what looks like 1 to 5, so it switched 4 positions. So B is going to go from what looks like 4 to 9, 5 positions to the right. C also went from 1 to about 5, 4 positions, and D went from about 4 to 9, about 5 positions. We put A prime, so this would be the pre-image. And this would be named the image. In 2 dimensions, we only moved in the X position. If we went over 2, or we went over 5 in this case, but if we moved it, we were 3 long. A double prime, B double prime, C double prime, D double prime. If I draw a dashed line, this moved to here, this moved to the D double prime, the B prime, and to the A double prime. Now these moved from 1 to -1, so it moved 2 over, 2 to the left, and B, for example, went down 2, 3, 4, 5, 6, and 6 down. So each, according to this one, as we translate, same size, same shape, translated down 2 and over and to the left 2 and 6 down. To do that also with vectors, I need you to understand the simplicity of a vector. A vector, if vector A was being added to vector B, it equals vector C, where we start and where we finish, tail to head, tail to head. This is the net vector of how much we change, but how did we define it? In this case, 2 to the left, 6 down. 2 to the left, 6 down. So this right here is the angle of which we slid down. Continue working on translations and showing them with vectors. If you have any questions with vectors, I will go back and fix up the previous skip lessons as needed, and let me know. Vectors can be confusing to people once you understand that they're all triangles, just all triangles. Everything we do, even with circles, we define lines in there and put angles in so that we can have triangles. Triangles really help us solve so many things. So, continue on, finish your lesson. Thank you.